Greetings, ladies and gentlemen, boys and girls. May I have your attention, please? We're talking about solving radical equations with, count them, not one, but two radicals. So I'm going to jump right in. We're going to follow roughly the same approach. That's a terrible box. That wasn't even like... Oh, now I'm thinking about it too much. I forgot how I draw a box. Where do I start? Do I do this? No. Ooh.
Yeah.
I think I do that way. All right. It's the sort of thing I've thought about it too long. I don't know how to do it anymore. Okay, I can't do that. I have to do it just like naturally, subliminally sort of thing. So here we go. Square root of, ready? X plus 5, all into the radical, equals 5 minus the square root of x. So doubly radical. Am I right? Now, what I'd like to point out here is that our general strategy is going to still be the same. I'm going to isolate a radical by itself on the one side of the equal sign and square both sides, no matter how much it hurts me. So let's do that. Hey, this radical is already by itself. So let's square both sides. And you have to square the entire side. Sides I'm referring to are sides of the equal sign. So this entire side is being squared. So let's see, on the left, square root of x plus 5 all squared.
X plus 5.
X plus 5, isn't that wonderful? Wow. And on the right, please don't. No! Super illegal. No. I'm crying on the inside. So, anyways, so this is a pattern. A minus b all squared equals a squared minus 2ab plus b squared. So I have to use a pattern. No matter how much it hurts. Terrible. So let's see. A, actually for some of us who aren't comfortable using patterns, it's not a bad idea to label this additional step of just, or label your, A and B just to make sure you got it right. But I don't require that step. So let's see. A squared will be 5 squared minus 2 times a, which is 5 times b, which is the square root of x, plus b squared, the square root of x squared. It's the theme song for the pattern. Perfect square trinomial results from the square of a binomial. Wow, that was amazing. That's going to be a hit song. What's great is that song's now on the internet. So, tell you what, open rights. I'm not copywriting that song. Feel free to use it. Anyone, go for it. You're welcome. 5 squared is 25. Yeah, make it your ringtone. Go for it. 25 minus 2 times 5 is 10, square roots of x, plus the square root of x squared is x, technically absolute value of x, but we're going to ignore that for now. All right, I want to point out, even though this looks equally crazy to the one above it, where we started, it's actually better. Because notice, originally I had 2 square roots with variables. Now I just have 1. All right, so that is progress. And what am I going to do when I have a square root with a variable in it? I'm going to isolate said square root. Okay, so let's get the square root of x by itself. So let me subtract 25 from both sides. And tell you what, I'll also move this x from both sides at the same time, simultaneously. Because I get to do 2 steps at once. X minus x is 0 x's, or blank, right? 5 minus 25 is negative 20 equals negative 10 square roots of x. Now, how do I get this root x by itself? You could actually, oddly enough, you could, because by squaring it, I am allowed to distribute over multiplication. And it wouldn't actually be that bad. But because this is conveniently divisible by negative 10, I will divide both sides by negative 10. I wouldn't mark you wrong for squaring both sides there. In fact, on the next problem, we may want to, oddly enough, evenly enough.
I hate when he does that. Look, he has the color darker.
Yeah, it's slightly darker. It's actually just a little behind the scenes. I'm selecting my colors from this, not from like a preset color thing because I have a harder time reaching those. And I'm trying to be swift, so my apologies. Square both sides, I'll get x equals, that's somewhere between those two colors now. Oh, I didn't square it. Square both sides, silly me. And I'll get x equals 4. And if I was to do a proper check, friends, guys, are we looking up the screen, following along? Plug a 4 in. The square root of 4 plus 5. Actually, let's just do the proper check. Square root of 4 plus 5. Is that equal to 5 minus the square root of 4? So that's the square root of 9. 5 minus 2. Square root of 9 is 3. 3 equals 3. Cha-ching! It works. We did it. Well done. We did it. We did. Question? Comment? Yeah, DJ.
Why can't you just add the square root of x to both sides of each other?
You could, but, okay, so this is the hypothetical situation that he's describing. You would then have this plus the square root of x equals 5. And then when you square both sides, you'd have to use the pattern on this part where a would equal that thing and b would equal that thing. So you could, and sometimes you may have to deal with something that ugly, but I don't recommend it. So, wow, that's a pretty great rhythm. So let's do one more example, just one more, just 2 total. So here we go. Don't think about the box, don't think about the box, don't think about the box. Aha, that's how I do it! I start at the upper left quadrant, go down, so I do a counterclockwise upper left. There we go. All right, so here we go. Square root of 3x minus 2 equals 1 plus the square root of 2x minus 3. All right, write that down, and we're going to conquer this together, friends.
Let's be friends together.
Yep. Better to be friends together than to be friends alone. Let's solve radical equations and then we won't roam.
How would you be friends alone?
I don't know. So let's see.
That last song is also really nice.
Yeah, Open Rights. Feel free to use that. You'll find that on Now That's What I Call Music, the album. They're probably on number like 32 by now.
Like 49.
Really? Wow. Well, now that's what I call a lot of music albums. So let's see. Square both sides. Because this radical was already isolated. You could subtract 1 from both sides and isolate that radical, but both of them are equally ugly. So I'll have a plus b all squared. Right? We're turning around, Carissa. We're following along. Right? This is good stuff. A squared plus 2ab plus b squared. That's a weird 2 right there.
Well, see, what was A in,
In the previous example? Or on this?
what would your A and B be on this?
A equals 1, and b is this entire square root.
Oh, no.
Yeah, this is going to be amazing. Amazing.
I'm gonna hate all of you.
So let's see. A is equal to 1. B is equal to the square root of 2x minus 3. And now I'm going to plug it in the pattern no matter how much it hurts me because this is the only way to do this right. So don't just like distribute your exponent over an addition just because you're trying to find a shorter, easier way. So plug it in. A squared is 1 squared plus 2 times a. So that's 1 times b is the square root of 2x minus 3 plus b squared. So that's the square root of 2x minus 3. Oh, extend that radical there. All squared. Whew.
So plus 2 square root.
Let's simplify this. 1 squared is 1 plus 2 square roots of 2x minus 3. Question, can I distribute this?
No.
No, because this would have to be in its own radical for me to do that. Okay, so valid point, just making sure. Plus, and what does this last term become?
Just itself.
Yeah, just
Stuff that cancel.
2x minus 3. I like it. I like it a lot because that cancels with that, right? So, all right. Now, notice we've done all that work. We've suffered through the pattern, and I now only have 1 radical remaining. So that's progress. This problem is longer looking, but is actually simpler. So what do I want to do with that radical? How am I going to solve for x? Isolate it. I'm gonna move everything away from this guy, so I want to get all of this side far, far away over there. So I'll subtract 2x from both sides. I'll add 3 from both sides.
Why? Why are you doing everything so quick?
I'm doing some simultaneous moves.
Wait, okay. Well, what just happened?
I'm getting this radical by itself.
I know, but where did you get minus? Wait a minute.
Oh, you guys are so lucky. Urgh, I wanted this to be x plus something because then we'd have a double pattern problem, but it isn't. Oh, you lucky dogs, you. Yeah. Well, it'll probably happen on the homework. Now.
-2 minus 1 equals +3.
Oh, you're making me so angry.
What's the matter? Talk about your anger. Let's get our feelings out here. Okay, what part? Ask me a question about any of this. Ask me anything right here.
Okay, just hold up.
Yep. I'm holding.
Alright, no longer angry anymore. I get what you did. Alright.
Excellent, right? Awesome. So yeah, I was just trying to save a lot of steps. Clearly you can see all my constants I put together just to save having to rewrite this over and over. Now, question. Maybe this is a statement. I might have premised this wrong. I could get rid of this 2 by dividing both sides by 2. Well, that's going to create fractions over here. So kind of like Seymour suggested that in the previous problem, that we could square both sides right there, instead of dividing by -10. I suggest that we do the same thing here because this is nicely divisible by 2. So I'm going to square both sides like so. Did I? Oh, okay. I'll have to go back and watch that video since I already deleted it. So, alright. Left-hand side is x squared. Easy enough. Right-hand side,
4 times 2x.
right. So I can distribute an exponent over multiplication. 2 squared is 4. Multiplied by 2x minus 3, the square root and then squared is just 2x minus 3. And when I write this, don't just write this way. Actually put that in parentheses because this 4 has to be multiplied by that whole thing. But you see that the square and the square root just canceled out, right? Like, is what happened for this guy, right? So, and I agree, let us distribute again. So I'll get x squared equals 8x minus 12. Ooh, I like it. So here we go. Looking at this, I have an equation. Said equation has a term that is quadratic. I have multiple terms. What do I do to solve a quadratic equation?
Bring the 12 and the 8x up and
Set it equal to 0. And these aren't like terms. I'm just trying to like squeeze them in here and here respectively. So I'll have x squared minus 8x plus 12 equals 0.
Oh. Don't die, please.
And now,
Come on.
oh, sorry, my bad. You're right. That was a preemptive scroll right there.
Why are you adding plus 12 to that? It doesn't even have the same thing. Because
I wasn't.
Put it over on that side.
I was trying to just like fit them in here and here. So that way it ended up in kind of highest degree to lowest degree is what I was doing.
Why is it 12 positive?
Because I added, to undo -12, I had to add 12 to both sides. Right. So step 1 for solving a quadratic is set equal to 0. Step 2, factor. Which actually I'm now starting to doubt whether or not this is factorable. Step 3, set each factor equal to 0.
It's factorable.
Is it?
Yeah.
Oh, the rest
Negative,
of the day.
-6 and -2.
Well, So to factor this, step 1, GCF. Nope. Step 2, perfect square pattern stuff. Nope, because 12 is not a perfect square. Step 3, hey, leading coefficient's 1. So let's just find the old vanilla factors of 12.
6 and 2.
1 and 12, 2 and 6, 3 and 4. Oh, okay. Whew. All right, it does work. 2 and 6 add to be 8. I like it. Whew. Yeah, that's exactly what I say. I didn't realize I was that predictable. X with a 2, X with a 6 equals 0.
Or negative. Or minus.
I like it.
You like it a lot?
Yep. And now I'm going to set each factor to 0. So either, right, if I've got two things that multiply to be 0, either x minus 2 is 0, or x minus 6 is 0,
Or both.
or both. I knew you were going to chime in. It's like you're my sidekick for these videos. This is wonderful. So let's see. Now I solve, add 2, add 2, add 6, add 6. And I get x equals 2. That was a different box. X equals 6.
I'm telling you, you do it different every time.
Wow. So those are my answers, unless...
Oh my gee, can you hurry? I have to go to the bathroom.
Okay. I'm so glad this is permanently part of this video now. Unless one of those do not actually work in the original problem. So sometimes you have to do formal checks. So if I try 2, 3 times 2 is 6, minus 2 is 4, square root of 4 is 2. 2 times 2 is 4, minus 3 is 1, square root of 1 is 1, 1 plus 1 is 2. So that one works. And does 6 work? Here we go, let's just verbally do it. 3 times 6 is 18, minus 2 is 16, root 16 is 4. All right, 2 times 6 is 12, minus 3 is 9. Square root of 9 is 3, 1 plus 3 is 4. 4 equals 4, guys, they both work. Yahoo! I'm going to double box them. Bam. All right, thanks for watching, internet friends. Bye-bye.